Crash Course Instrumentation, Diagnostics, Episode 6, Designing for Diagnostics. Make troubleshooting easier before it starts. Welcome back to Crash Course Diagnostics. This is our wrap-up episode in the Diagnostic Fundamentals series, and we're flipping the script. Instead of just reacting to problems, we're asking, how can we design systems that are easier to troubleshoot from the start? Because the best time to solve a problem is before it happens. Let's dive into the habits, tools, and system design tricks that smart techs, engineers, and designers use to make diagnosis smoother, faster, and more reliable. Label everything. Yes, everything. When systems are down, time matters. Searching for a mystery wire or tracing a schematic with no reference is frustrating and wasteful. Label wires, fuses, terminals, switches, and devices. Use durable, legible markers. Pro tip: label both ends of a wire. If it disappears into a conduit, you'll thank yourself later. Industrial best practices recommend unique wire numbers tied to documentation, not just black wire number 2. Use temporary wire markers or color-coded tape for short-term jobs. Just don't forget to leave a buddy tab, a folded-back tape tail that makes it easier to remove later. Use diagnostic LEDs and indicators. Built-in visual feedback is your first line of defense. A simple LED can tell you power is present, a signal is being received, a relay is activated, a fault condition exists. Designers include test mode indicators, status LEDs, or blinking fault codes whenever possible. Some systems even show blink patterns tied to specific fault codes. This saves hours during fieldwork. Add test points. You shouldn't have to unscrew terminals or backprobe connectors just to test a signal. Provide accessible test points for voltage, current, logic levels, communications. These can be banana jacks, loop taps, or even software-readable diagnostic addresses in digital systems. Great diagnostics is about accessibility. Leave space and access. Cramming everything into a tight panel might save space, but it makes diagnostics painful. Leave finger space around terminals, documentation pockets, and hinge room to open panels safely. Think about future maintenance when designing today's system. Keep good documentation. Schematics, wireless, loop drawings, panel layouts. Keep copies near the system in a waterproof folder or posted inside the door. Better yet, digitize your documentation and link it via QR code on the panel door. A system without documentation is like flying blind. ESA standards recommend maintaining an updated equipment folder at the system. Include manufacturer manuals, field changes, schematics, and test records. Use the manufacturer's troubleshooting section. Most OEM manuals include a basic troubleshooting table. Use it. These flowcharts, fault codes, and quick check suggestions often get overlooked, but they can save time and point you in the right direction. Always start with the manual when in doubt. Encourage notes and logs. Encourage field techs to keep service logs and repair notes. These logs help the next person solve problems faster, especially with intermittent faults or previous workarounds. Maintenance software or even laminated log sheets inside the panel can preserve valuable tribal knowledge. Train for diagnostics. The best diagnostic systems are only helpful if people know how to use them. Provide training, walkthroughs, and fault simulation scenarios to sharpen the team. You don't rise to the occasion in diagnostics. You fall back on your preparation. Reinforce the 3 questions every tech should ask. These 3 questions are timeless because they work. 1. What is it supposed to do? 2. What is it doing now? 3. When did things change? Ask them before every job, every test, every replacement. They guide your logic and reduce wasted steps. Historical spotlight: Xerox PARC and fault-tolerant design. In the 1970s, Xerox PARC engineers worked on fault-tolerant computing systems that could diagnose and repair themselves. They included internal monitoring, logging, and modular fault isolation before the term self-healing systems even existed. Their lesson: design for failure. Before it happens, and you won't fear it when it does. That mindset lives on in modern PLCs, server farms, and industrial automation systems today. Wrap up. Diagnostics is a design philosophy. The best troubleshooting starts before the fault ever shows up. Whether you're an installer, an integrator, a designer, or a field tech, you can build in tools that make life easier for everyone downstream. Label more. Test smarter. Document everything. Train well. Use your manuals. Leave helpful notes. That's how systems get safer, faster, and more reliable. Like, share, and subscribe for more from Crash Course Diagnostics. Massive thanks to Tony Kufholt and the open source community that built the ModEL framework. We'll see you next Sunday, and if you missed any previous episodes, check out the full playlist below.